Power and energy. Energy makes things happen. From the smallest pulse of electricity to a blast of explosives. Energy is measured in joules. Power is the rate at which energy is converted from one form to another. Measuring power. Power can be calculated by taking the amount of energy converted and dividing it by the time taken. The more energy that is converted in a set period or the quicker a specific amount of energy is converted, the greater the power. That means that an 1800-watt electric heater can convert 3 times as much heat energy per second as a 600-watt model. Units of power. Power is measured in a number of ways and exhibited by many different things, including engines, appliances, and people. A watt is equal to 1 joule of work done or 1 joule of energy converted per second. The rate at which a light bulb converts electrical energy into light is measured in watts. The higher the number of watts, the higher the power. A kilowatt is 1000 watts and is a useful measure of electricity used by large engines and appliances. A megawatt is equal to 1 million watts. Only huge machines can generate power on this scale, including power plants, aircraft carriers, and supercolliders used for particle physics experiments. 1 kilowatt-hour is equal to 1000 watts used for 60 minutes, or 3.6 million joules. The amount of electrical energy used in a house is usually monitored and measured in kilowatt-hours. The power of vehicle engines is often measured in horsepower. 1 horsepower is equal to 746 watts. Brake horsepower simply means that an engine's energy loss due to friction has been accounted for. Energy conversion. The law of conservation of energy states that energy cannot be destroyed or lost. It can, however, be converted from one form to many other different forms. Electricity is a particularly valued energy source because it can be converted into sound, heat, light, and in the case of a motor, movement. Chemical energy is the energy stored in the bonds of chemical compounds, from foods and batteries to fossil fuels. It can be released through chemical reactions, which break the bonds between atoms. For example, burning a fossil fuel such as coal converts the chemical energy stored in the coal to light and heat. Kinetic energy is the energy an object possesses because it is moving, such as a person sprinting or a skier traveling downhill. There are various types of kinetic energy, including rotational and vibrational energy. The amount of kinetic energy an object has depends on its speed and mass. Mechanical energy is the kinetic energy of an object combined with its potential energy, energy that is not doing any work but can be converted, arising due to an object's position. An example is a compressed spring, which releases its potential energy when it bounces back to its original position. Thermal energy is technically a type of kinetic energy derived from the vibrating movement of atoms in a substance. Heat describes the flow of thermal energy from one place to another, such as the heat transferred from a flame to a cooking pot on a stove. Fossil fuels. Around 2/3 of the world's electricity and more than 1 billion motor vehicles and other machines are powered by fuel derived from the fossilized remains of once living things. These fossil fuels, oil, coal, and natural gas, are non-renewable resources with limited reserves. When burned, their chemical energy transforms mostly to heat energy but with significant emissions of greenhouse gases. And there you have it. Hope you enjoyed the video and learned something new. Let us know what you would like to learn about in the comments. Also, remember to like this video and subscribe to the channel. We'll see you again soon.